Hello guys, in this video, we are going to see how we can build a machine learning system that can predict what is the medical insurance cost of a person. So let's see the workflow. Uh, so let's see our problem statement that there is a medical insurance company. This company wants to create automatic system that can predict what is the medical insurance cost of a person, which will be like what will be the medical insurance cost of a person will be, and we need a machine learning system that can learn from the data and it can predict what this price can be. First step is to collect the data. Here we need insurance cost data, and our machine learning algorithm will learn some parameters like uh, what are some health issues that the person had, and what is the gender of the person, and other such kind of things. And based on this insurance cost, um, the cost varies. So we need this data to feed our machine learning model. Once we have this data, we need to do some data analysis to understand the data. So data analysis helps us to gain the meaning of the data, the like the data which has the meaning of the data, that what data has to tell. So next part is data pre-processing. And once we have the data, we cannot feed directly to the algorithm. We need to do some processing. Once we process the data, it will be compatible to go into our machine learning model. The next step will be to split our data into training and test data. So we train our machine learning model with the training data and test our model with the testing data. To check performance of our model, we use evaluation metrics, and then we feed this training data to our machine learning model. So in this case, we are going to use linear regression model. Once we train, we will evaluate this model. So let's start. We will be doing our coding in Google Colab. So here we will first upload the insurance data. So I will give this insurance data set in the link will be given in the description box. So now let's start with importing the dependencies. So import numpy as np, pandas as pd, import matplotlib dot pyplot as plt, and import cbon as SNS, and from sklearn model selection, import train test split from sklearn dot linear model, import the linear regression from sklearn import matrix. So in this project, we will be using linear regression model. So let's run it. So NumPy as NP is used to create NumPy array, and pandas is useful for making data frames. Seaborn and Matplotlib are used for plots and graphs. And that's it. And let's start loading the data from CSV file to the pandas data frame. So insurance dataset equal to pd.read CSV. So our dataset is loaded in the insurance dataset. So we will proceed. So now let's check the first 5 rows of the data frame. So insurance dataset dot head. So these are the first 5 rows of the data frame. So you can see the charges column, which is our target target column. So now let's check for the number of rows and columns. So insurance dataset dot shape. So we can see that there are 1338 rows and 7 columns, which there are 6 feature column and 1 target column. That is our the charges is the target column. So now let's get some more information about the dataset. So that we will do by using the info command. So I will take that insurance dataset dot info. So you can see the information of various feature columns. So there are like 3 categorical features, like the sex and smoker and the region column. So we'll first check is there any missing values or not. So we'll take that insurance dataset is null dot sum. So you can see our data set is quite clear that there are no missing values in the data set. So let's perform some statistical measures. So insurance data set dot describe. So you can see there are the description of this data set. So there are count, mean, standard deviation, minimum, 25 percentile, 50 percentile, and like this value is 39, like 50% of this value are less than this 39. So let's check for the distribution of age value. So SNS dot set. figure fixed size equal to, let's take 6,6 and SNS dot this plot insurance data set. We'll take this age column and PLT dot title will take the age distribution so finally we will write PLT dot show. So this SNS dot set like gives us some better theme plots. Like if we want grades in our plots, so we use this SNS dot set, and this distribution plot tells how values are distributed throughout the data set. So let's see. So you can see that the age value from 10 to 70, there are maximum density and most number of values in this 20, 21 and 22 range, whereas in 23 and 24 to about 70, the distribution is almost normal. More number of people in our data set are of age 20, 21 and 22. So let's proceed with the data visualization for the gender column. So we will just copy this and we'll change this plot to count plot, and count plot we have x equal to x column and data equal to insurance data set, and it is for the 6 column distribution. So let's run it. So basically this count plot is used to plot categorical features. So here the count plot gives the number of data points for male and as well as the female value. So you can see there are both are in between 600 to 700 range. So let's find the exact value. So insurance data set dot value counts. So there are 676 male and 662 female. So let's follow the same process for the BMI distribution. So we'll take this. Copy it. So this is for the BMI distribution. So we'll insurance data set. Instead of age, we will write BMI. And we will give the title as BMI distribution. And we will run it. So like BMI represents the body mass index. So it tells whether a person is overweight or underweight or normal. So this kind of distribution as normal distribution, like more value are in the mid range. You can see the more value are in the mid range. So it's a normal distribution curve. So and similar kind of distribution is either in either this peak, like um, so it's kind of normally distributed. So like BMI is BMI calculated weight, height, and BMI is calculated by using the height and weight of a person. So if BMI is less than 18.5, so generally it signifies the person is underweight. And if BMI is in between the range of 18.5 and 24.9, so it's kind of normal. So if BMI is greater than 24.9, so the person is said to be overweight. So the normal range is in between 18.5 to 24.9. So let's see what are all columns are there. So there is a children column also. So let's take this column and visualize what is in this column. So for that I will use this. So instead of sex, I will write children. So title will be, let's say, we'll keep it as children. So we'll run it. So like children column, in this case, instead of using the displot as it is a numerical column, we can also use a count plot, because children column contains only 6 values. So we can use count plot also. So I have used count plot here. So let's check the exact value of each. So we'll do that. Students dataset. Children dot value counts. So like we see more number of people who doesn't have any children. So like one people had like one children, and there are 324. So as the number increases, so we can see the value of children also means like 5 children. There are only 18 people which have 5 children. So let's see. Let's visualize. Let's see what our columns are left to visualize. So there is a smoker column. So we will visualize this column. So I will use this count plot only. So our X value will be our smoker column. Smoker column, and instead of children, I have to write smoker. So I will run this. So you can see that around 230 or 240 around people are like 250 around people are smoker, and like there are 1000 around people are a non-smoker. So let's check the particular values of each. Insurance dataset, smoker column dot value counts. So you can see that exactly 274 people are smoker and 1064 are non-smoker. So let's check which region is which this region column is left. So we'll visualize it. So again, I will copy this same thing and paste it here. And instead of smoker, I will write region. So I will run it. So you can see that different values for the southwest, southeast, northwest, and northeast region. And let's check the particular value of each region. So we'll take the insurance data set, region, dot value counts. So you can see that southeast there are 364, southwest 325, northwest also 325, and northeast almost 324. So like what are columns are left? You can see there is a charges column. So we will visualize this column also. So charges will be a numerical column. So I will take the disk plot. So this will be charges. And charges distribution. I will run it. So we have a lot of data distributed in 10,000 values. So we have very little values which are going around 30,000 and 40,000. This is how our charges is distributed. So this is the data analysis part. So now we will move towards the data pre-processing part. So like we can see that there are three categorical column. Like there are three categorical column, that is the sex column and the smoker and the region column. So we cannot feed this text data to our machine learning model. So computer won't understand this text value. It understands the numerical value. So what we are going to do is we create numerical labels. So we will do encoding so of that sex column, smoker column, and the region column. So let's do it and give a particular numerical value to each data set in that column. So insurance data set dot replace. First, we will take the sex column. So there are two values, that is male and female. So male will replace it with 0 and female will replace it with 1. And we will close this and in place equal to true. So basically we are encoding and categorical value into a numerical value and assigning some numerical value to each of the data set. So we are using this for the sex column, and the same thing we will do with the smoker and the region column. So I will copy this. So I'll change this text column as smoker. And smoker, if there are two values, yes or no. So if it is yes, then assign it with 0. And if it is no, then assign it with 1. So again, we have to do the same with the region column. Region, like there are, I guess, southeast, southwest, northeast, and northwest, 4 regions. So I have to assign values to all the region. Southeast, we will assign it as 0. Then southwest, we'll assign it as 1. So again, northeast, we'll assign northeast as 2. And the northwest, we'll assign it as 3. So we'll run this. So our like encoding is done. So now we will split the feature and target columns. So X insurance dataset dot, will drop the charges column. X is equal to 1 and Y equal to, we'll keep the our target column here. So target column is our charges column is our target column. So like here axis is 1. So as we are removing column, so if we will be, if we would remove any row, then we would have written axis equal to 0. Here we are removing the target column, so axis equal to 1. So we'll run it. So now I will see the print the value of X and Y. So print X. This is our X value, and we will print the Y. So this is our Y value. That is charges column value. So now let's start splitting the data into training data and testing data. So we will do that. X train, X test, Y train, Y test, train, test split, X, Y, and we'll give the test size as 0.2. And we will provide a random state equal to 2. So we'll run it. So random state equal to 2. It's just to reproduce the same code. Like your code will be same as mine. Like data will split in the same manner. So and test size equal to 0.2. Like 80% of the data set will be used for the training purposes, and remaining 20% will be used for our testing purposes. So let's check the value of X, like in the original value, as well as like how many of the data set are there in xtrain and xtest. So we'll print that value x dot shape comma xtrain dot shape as test dot shape. So, or in total, our original data set contain 1338 values, and that is split into that 80% of it is splitted for xtrain and 20% is splitted for the xtest testing purposes. So now we will start our model training. So here we will be using the linear regression model. So like when we use a linear regression model, it tries to fit the data in a straight line. Like so, its linear regression is like also called as a line model. So let's start loading the linear regression model. So now we will train our model. Regression.fit our xtrain value and the ytrain value. So our model is being trained. So now we'll do the prediction on the training data. So training data prediction equal to regression dot predict xtrain so here we will use R-square value. So let's see the R-square value for training data. So R2 train equal to matrix dot R2 underscore will pass the ytrain value and our training data prediction. So training underscore data prediction. So we will print this value, print R squared value R2 underscore train. So we'll run it. So our R squared value is of a training data set is like 75%. So like R squared value 75% means like 75% of the data fit the best in our model. Like 75% of the data fits into our training model. So let's do the same procedure with the test data. So I will copy this. Just I will change it to test data training prediction data prediction, and I will pass the value of x test. Run it. Again, we'll copy this. Instead of train, I will use the test. test data prediction, and here also we'll pass the test value. Can see that there are almost 74% our testing data. The R-square value is around 74%. 74% of the data set fit into our model. So like here we don't have overfitting in this case. So let's start building a predictive system. So I will take the input data. So this is the insurance data. So let's take a random value and let's take this value. But remember guys, we have changed this column, this categorical column to our means numerical column. So we have to change this also because our model is trained based on the changed changed data set. So we have to change it we have to do it manually. So for female, we have taken 1, and so for no, we have taken 0. And for Southeast case, we have taken 1 as an input. So let's cross check with the previous column. Last one is the charges column. So let's remove it. For no and Southeast, we just have to cross check it once again. We have replaced no with 1 and Southeast with 0. Southeast with 0 and this one with 1. So that's it. So now we will change the input data to NumPy array. Input data as NumPy array equal to np dot as array. We'll pass the input data. So now we will reshape the array as only one single instance is taken. So we will reshape it. So input will replace reshape it. So input data, our reshape data. So reshaped. So our input data is numpy dot reshape, and we'll pass 1 comma -1 as it's only calculated for only single instance. So we will do the prediction equal to regression dot predict. So our input data reshaped and print prediction. So we just will be printing the in a very formatted way. So print the insurance cost is USD, our prediction value. So PRE 0. So let's see what our model is showing. So it's around like 376. So the insurance cost is around $3,760. So you can see it's like almost closer to this value 3756 as this instance we have taken in as an input. So like it's quite close to that. So it means that our model is working fine. So that's it. So hope you have enjoyed this video. Thank you.